Hi, I'm David Sencock. This is Steve Clark with SI Testing. And today we want to talk to you about another side of our company, more than just the electrical, but a side that we deal with when it comes to the HVAC system. Years ago Steve and I were involved with a webinar, or actually a seminar. And in that seminar, we talked about the heart and lungs of the building. We talked about the heart of the building being the electrical system. The electrical system shuts down, the building doesn't run. Another key component is the lungs, and that is the air. And there's a lot of misunderstanding about it because it's kind of hidden. It's up in the space and no one really knows what goes on with it. But today what we want to do is we want to talk about, we have a couple programs that deal with better air delivery, and it deals with energy efficiency. And I want to introduce to you Steve. Some of you know him. Him and I go back about 20 years. And I'll let him tell you his story on air. But I want you to see from an expert's point of view what is involved with the system and then what you need to do to get the most out of it. So, Steve?
Thanks, Dave. Well, I started as a marine engineer. My training and background's with the U.S. Merchant Marine, and part of that training were the design classes or the degree classes, the thermodynamics, fluidics, physics, material science, blueprint reading. All these skill sets that I was trained in enabled me to operate ships worldwide. I could walk onto a ship and within a few hours be capable of operating it as an engineering officer in charge of the watch. So those kind of skills I was able to apply in the building industry. I joined ABM Engineering in the late 80s and was a certified chief engineer operating facilities for various locations, aerospace, commercial high-rise. Part of my work led me into research and development with 3M filtration products, and that really started posing the question and my focus in the HVAC systems. We were finding systems out there throughout the country that were running far out of parameter. Design parameters called for face velocities of 500 feet per minute, and air handlers were operating at twice that. Couldn't maintain static air pressure. We had pressure problems in the building, tenant complaints. So that told me that this is an area that's neglected and probably not really fully understood, because as you said, most of the equipment in the HVAC system is not visible. It's hidden above the ceiling, behind fire-rated walls. And there are a lot of busy components back there that can cause failure. As part of this field, I became LEED accredited because we saw that the U.S. Green Building Council saw the need and the desire for people to become more efficient in their operations and to make it a sustainable operation and keep the tenants comfortable. It's very important. I became NAFA certified. That's a National Air Filtration Association. You need the background knowledge in these fields to know what you're doing when you're dealing with air filtration and HVAC systems. So it really became an area for me to apply the skills that I was trained in, but focus in an area that most people don't like to work in. My dad was pretty wise in advising me that find something that nobody else wants to do and get really good at it. Well, I never really enjoyed getting on a ladder and going above the ceiling and messing around with a VAV box. I knew the last thing I wanted to do was pop up in there and get the ceiling tile and insulation on me, have to come back down and go deal with a tenant. So you could see there was areas that don't get a lot of attention. Engineers are great. They change air filters. They maintain the equipment. We operate efficiently as we can. But these buildings that we're presented with have been taking themselves apart since they were built. The systems are constantly in disrepair just from their operation. And so I found that throughout the tours of the country and the hundreds of systems I've looked into, that there's a pretty common thread out there and points of failure that we can solve. We can take care of these issues.
Let's talk about the system, because I get a lot of building engineers watch these videos. Some very experienced, some new in the trade, some don't know a lot about it. Especially when it's just going from the prime mover to the delivery system and filters and stuff like that. Give kind of an overview and look at the system as a whole so people understand what we're talking about here.
Sure, Dave. I always like to start at the beginning. The air filters generally are the beginning of your HVAC system. They're there to defend the system, the building from particulate intrusion, contamination, and that's at the air handler generally. Air filters are ranged from very inefficient to ultra efficient, and there's different applications for different facility uses. In the LEED world, or U.S. Green Building Council, we're trying to promote MERV 13 or better. And it's to protect the machinery, protect the occupants, prolong equipment life. So those areas there, it's not just the physical filter itself, but I've walked into filter banks and found them shaking and loose, in disrepair, just from the years of operation. We get a note on our calendar that says, hey, tomorrow you're changing the primary filters. The budget comes up and says, okay, here's the money, spend it, go buy those filters. We look at the magnehelic gauge to see what the pressure drop is across the filters. Most of this is really calendar driven. The magnehelic gauges generally aren't calibrated. If the filter rack is leaky and you've got bypass around the filters, it's not getting you an accurate reading. That gauge is to tell you how loaded those filters are, how dirty they're getting. So right there, we see the problems at the beginning of the system. You work your way into the system deeper, the coils, the heating coils, the cooling coils, critical pieces of equipment. This is where the magic happens, that interface of chilled water with the air coming through it, that magical equilibrium of heat transfer. That's all done with very calculated velocities and pumping rates. The fans themselves. Over years, I've walked into air handlers and I found spare pulleys laying in the fan room floor, belts laying off to the side. Through the years of building operations, a lot of them would become lower on their output. So air balance companies would come in, they'd read the air, say we need to speed the fan up, get more air delivered. So you'd see these changes. In years after that, variable frequency drives came into play. They would be matched, but not accurately matched to that air handler. So you could have a fan running at 60 hertz and it's got 1,000 feet per minute, twice the design velocity that it should have. It was never correlated with the proper sheave size. You had a sheave change, added a VFD, and now you have some tribal knowledge that this air handler is running way out of capacity. I've even found air handlers running so far oversped that they've fallen off the fan curve. And that's when the design output is diminished because you've run the fan too fast. And that's a detriment to the system. The dampers inside the system, things we don't even see unless you get into the ducts themselves. There could be damage to the control dampers, isolation dampers that are frozen open, fire dampers we know have to be inspected by code. Luckily, there's an access door, you can generally see it, but there's turning vanes that never get observed. We found turning vanes completely collapsed and twisted, debris, insulation blanketing it, loss of airflow. When you look at the points of connection in the system, and this is anywhere there's a mechanical connection point as far as the ducts themselves or high pressure taps.
So we're leaving the prime mover,
Mhm.
the actual unit,
Mhm.
actually going to the delivery system.
Right.
So that way people kind of know what we're talking
Right,
about. We're
right.
talking about those mechanical connections where the ductwork's put together or the taps are put on.
Right.
Right there. Okay.
And as part of the assembly process, there's a very intricate gasketing system. The duct mate gasketing, for instance, if it's not done in the proper sequence, most of that gasket gets extruded into the duct. You'll find areas where the duct sealant was applied on the outside of the seams and it looks like bubble gum that's frozen in time because it was blistered up during the curing process. High pressure taps or the TYs where the ducts branch off. A lot of tabs aren't bent. There's air gaps between them. During the assembly process, there's so many points of connection that can fail. And then as you operate it over the years, you end up with multiple points of connection with multiple failures. I always thought there would be this euphemistic smoking gun of a duct leak when you'd walk into a building. And you find that one big hole in that trunk hidden behind a wall. It's very rare when you find that one big smoking gun. Most of the leakage and problems we find are cumulative effect. It's like having a soaker hose in your garden. Nothing's going to run out of the end of that hose, but you're going to soak everything else in the building. And we got to remember, air is a fluid. It's not a liquid, but it is a fluid, and it acts the same way as any other fluids do. Path of least resistance. And if it was a liquid, we'd have stains all over our ceiling tiles because there's so many leaks above the ceiling. So when we walk into the facility and we see all these potentials, hundreds and hundreds of points of failure, gaskets at fire damper access doors, air handler accesses, penetrations where we've even seen fire sprinkler systems routed right through a main duct. And it's amazing that once the duct is installed, you can't keep track of what's happened above the ceiling after that ceiling tile is put back in place.
So let's do this. Let's take it so people get an overview of you have a fan. Air is delivered through ductwork. A lot of places aren't even doing T-bar sealing anymore, and some have T-bar. So the idea of the fan is to take it through the ductwork and to deliver it into the space. Let's just take a second because there's a certain spot I want to stop here, and then we're going to move on to like problems. Let's talk about problems in the system, how that will be seen, talking about the building envelope, the occupied space, and stuff like that. But how does that work? So people understand it and looking at it. When it leaves the unit and it's going through the ductwork, how's that air supposed to be delivered, and how's that exchange supposed to happen?
Okay, great. When you design an HVAC system in a facility, you base it on the usage of the facility, the occupancy, the number of people. So there's a design volume of air and velocities of air that we adhere to. So a 20,000 square foot floor plate, which is a pretty standard floor plate, you're looking at about 20,000 CFM or cubic feet per minute of air coming out of that air handler. You need that air in the occupied space. That air is there for many reasons. Obviously ventilation, conditioning, all the comforts that we're trying to recreate an artificial environment for the occupant. When you start hitting all these problems in the distribution system, from the seals at the air handler, to the bad turning vanes, to the control dampers, each one of these has a tendency to either slow the air down, restrict its movement, lose the capacity in the system, which is static losses. That end controller at the zone out in the air register or in the occupied space is the variable air volume box. They require a minimum of 0.75 inches of static pressure. Things don't react well to low static pressure. You end up with inaccurate settings and controllability is lost. So you'll have areas in an occupied area in a floor that have different temperatures, humidities, and conditions just based on your infrastructure. We own our own solution in these buildings. We have the capabilities to operate them because they were designed well. They were designed per code. They're just running with more than 20% leakage factor calculated in, and that's an old rule of thumb. And nowadays, it's less than 5% is acceptable. In many facilities, you need a less than 1% leakage factor. It's the capability of maintaining the environment in the occupied space and doing it efficiently and sustainable, trying to maintain this on into perpetuity. So it's a very, very complicated system that many people, they like you said, you throw the light switch on, hey, they don't know what goes behind all that energy and the distribution and the safety and all the faults that can happen just by throwing that light switch on. Same thing in the HVAC system.
So if a system is designed, it's supposed to deliver 20,000 CFM. So it's supposed to go through the ductwork. It's supposed to deliver that 20,000 CFM. There is a return to bring back that air, so we get an air exchange that comes back in, that gets certain mixture with outside air, goes back through, gets filtered and all that stuff. That's how the system is supposed to design. So you've already started hinting about, you talked about duct leakage, you talked about problems and not delivery. What I want us to do is I want to take it from here, and let's talk about those problems, because I think what happens is a lot of people are out there and they have buildings that are, I like to say, they wish they were 5 to 10 years old, but they're dealing with buildings that are 20, 30, 40 years old, that were designed a certain way. They just expect that when the system says it started, it works. There's no problems. They change their filters. They get calls that it's cold, it's hot, it's not good air. People are tired in this area. People are wearing sweatshirts over here. People are wearing shorts and tank tops over here. Let's take that. We'll stop here. Let's take it from here, and then let's continue the conversation and start looking at some of the problems, how to identify those problems, and solutions for that. Is that fair?